So I want to give a quick run through on how timers work in Allen Bradley PLC programming. But first, in order to know how timers work, let's know how they work in real life. Typically, we have some type of relay that is set up to be a timer. In this case, this is a timer that can go both on-delay, off-delay, and one-shot setups. But we're only going to, you can see that right here on the switch here. But right now, it's set up to be an on-delay timer. And an on-delay timer, as you'll see in a second, it is once I trigger an input to the relay, it's going to time for the 3 seconds, and then the light's going to turn on. And then once I release the input, the light drops immediately. So input, time, then it turns on, hence on delay. Now, there is another type of timer that's called an off-delay timer. And it will work kind of like this. I push the input, and the light automatically turns on. And then once I release it, that's when the timer starts timing. So input energizes, light turns on, and then once I release the input, that's when the timer starts timing to whatever the setting is. So they both have their purpose. An on delay allows you to start something later after initial input, so maybe motors cascading or stoplight. An off delay allows, think of it as the lights on this room. So if I had a motion sensor on in there, anytime it sensed me, it would keep the lights to stay on, but that once I leave and it doesn't detect a signal, it will turn off after a set amount of time, like a fan blower in the exhaust area. So this is a way of saving money, but this is the hardest one for people to get. Well, we can program in Allen Bradley land this way. Okay, and here's our Allen Bradley software, but the one thing to keep in mind, this is a basic setup of what we would do with a timer setup. 2 important things. 1, up to this point, we've only been programming with these bits here. And then, of course, the XIC, where they're looking at bools. Bool is the data type. And if I have a push button, that's a bool. It's only 0, 1. In this case, though, we have its own data type that we use for timers, because a timer utilizes kind of a package of data types. And let's go into our parameters and tags to show you. And if you take a look, I already have 2 data types, two timer bits here. And if I hit the plus sign, you'll see that a timer, let me expand this, and a timer consists of 5 different things, you know. And if you look over here to the right, you'll see 2 dints and 3 bools. You know, these are bools here, because these are only going to be on or off depending on what they are. Let me delete that. And the dints are actually going to take the time. So if you take a look here with the accumulated and the let me put up a text box here. Let me do a notepad. So that you can physically see. So anything that's an ACC bit, that is the accumulated bit for the timer. Okay? That's the accumulated bit, and that's a dint. A pre-bit, that's your preset bit for the timer. This is also a dint, and something to keep in mind that it's in tenths of a second, or not tenths, thousandths of a second, so milliseconds. So 5,000 in this setting equals 5 seconds. 10,000 equals 10 seconds. And if I do like 100 Or if I do 10, that's 10 milliseconds. Okay, so keep that in mind as you set things. And the same is true for the accumulated side, okay? So the other bits are the enable bit. That's a bool that tells me that the timer, that there's power to the timer. That's important to keep in mind, timer. A TT bit, which means the timer is actually timing. Timer, no, yes, timing. And then there's a DN bit, which means the timer is done timing. Okay? Usually, we're going to program off of this one because we usually want, or these two here, because we want either something to be timed on in some way and then turn off, or we want something to be turned on after a given length of time. But that's not always hard and fast, a hard and fast rule. So depending on the timer, these have different aspects of how they function. So, but that is what each of these bits are, and all of these are bools. So bool, bool. And if I zone in here, you can see the accumulator, done, enable, preset, and timer bit. Those come already packaged as a timer. So think of it this way. If you're going out to buy a set of screwdrivers, you can buy a screwdriver one at a time. But if I want to make sure everything is there, I buy the whole set. In theory, you can't really do this, but in theory, I could create a dint, a bool, a dint, and a bool. But knowing, chances are you'll forget something's there. So Allen Bradley has you buy the set automatically to make sure everything is here. That's why we use the timer data type. And this is how we could program with this. So here I have a push button that's going to turn on a timer with a preset of 8 seconds. There's the accumulated. I have a bit that when this bit's on, the light turns on. When the timer's timing, this bit's on. When this is on, then it turns on. So I'm going to download this and I'm going to run this. Now you're not going to see any lights on behind me because I'm just using memory bits just because it's easier. So I'm going to go online. And you'll notice if I toggle that bit, you'll see that the LT is on, LT2 and LT2 is on because this is still timing. But once this hits 8,000, so when the preset equals accumulated, the timer turns off, the done bit turns on, but notice the enable bit is still on. This will stay on as long as everything over here is sending power to the timer, okay? And you can see that enable bit right there. You can see the done bit right here. So once I toggle this bit, notice what happens to light 1 and light 3. So I toggle that bit, everything turns off. I'm going to just toggle this on for a little bit. Notice here's the TT bit and the enable bit, but if I turn it off, the done bit never turns on. So this works just like an on-delay timer, as I showed you in the beginning, except that once power drops from this rung, this resets its time and it starts timing again, just like an on-delay timer. And it hits, when the accumulated hits the preset, the done bit turns on. The timer bit is on when the accumulated is less than the preset, and this bit is on anytime power gets to the rung. In full disclosure, I use the on-delay timer more than anything because I understand its principles. It's pretty straightforward. There's a bunch of fun things I can do with it. So let's change this to an off-delay timer. And to change it, all you gotta do is click on the timer itself and just to go down to a TOF. This is an off-delay timer. Pretty straightforward. I'm going to download this again, and then we're going to see how everything works. And if it's an off-delay timer, you're going to notice that the enable will turn on automatically, and the done bit's going to turn on automatically, but the timer bit isn't going to be on once I toggle this push button. So if I toggle this push button, you'll see that these all turn on, and notice nothing is timing. But watch what happens when I toggle this bit. This is going to drop out, and this is going to turn on. Because there's no power getting to the rung, and it starts timing, and once the timer elapses, both of these knock out. I had a student once do a stoplight with all off delays, and I was like, I don't know how he did it, but he did it, and it worked. It's possible, but I'm just not good with off delays and programming. There's a time, really good for watchdog timing, but that's how. So I'll do it again, toggle the bit, and you can see the done bit stays on, the timer bit stays on, and while it's timing, both of these are the same. So just keep that in mind as you move forward. That's how an off-delay timer works. Allen Bradley has one more set of timers, and that's a retentive on-delay. And it should look just like an on-delay timer, except for one big difference. Notice there's no power going to the rung right now. If it's an on-delay timer, shouldn't that drop to 0? Yes. With retentive timers, you need a second thing with it in order to reset it, because if you don't have it, then it will always stay up here. And in this case, I'm going to just put if you look under timers and counters, you'll see an RES command that looks like this. This has to match your timer name. And if I want to reset it, I got to toggle that bit. Now, in theory, you can use this reset at any time for any type of timer. But this is where it works with the retentive timer. So now watch me toggle this bit. Timer enable, it's off. But notice it keeps the time. And these bits only turn on while this is timing until it gets when the preset hits the accumulator. And if I turn off the bit, notice the done bit stays on because it reached it. If I turn it on, it doesn't keep timing, it just caps out there. But the only way to reset that done bit is by engaging the rung that has a reset. So this is the base level stuff. Let me teach you a couple little tricks, because if you're watching this, you probably want to know some timer tricks. And I'm going to go offline. One thing in the past that you could do with Allen Bradley and the Slick 500 is you can use a clock bit that has a frequency to do blinking lights. Well, you can't really do that as well anymore without doing a little trick. So I'm going to put a kind of a two timers here. Each one is going to have its own timer. Now, if I want to create a timer bit, I could just type in here. I have another one made, but I'm going to just show you. I have one here. You can just right click and do new, and it'll give you the right data type every time. And let me do 500. Let me match this to 500. Okay. It's always going to stay on, except what I'm going to do is I am going to put a done bit on the done bit of this one, T-timer 1. And I'm going to put the done bit of the other to power this on. Oh, forgot the done bit. There. So in this case, when it gets to here, if this timer isn't timing, this is going to time. And then once it hits a half a second, it's going to hit the done bit on, and that's going to trigger this time right here. Okay? And then once that times out, it's going to just disappear. And if I want to get a light to blink off of that, let me close that. All I will need to do is base a light off the first timer's done bit. And this is automatically going to go. And you should notice that this will blink. And if you want, I can put a light in the back. But I haven't added any hardware, so that's why I'm being lazy. But you can see it blinking. So if we need a blinky light, this is the commands to do. Because, and you notice, you don't notice this dropping off because it only drops off for a millisecond or one scan cycle. But this is basically staying on the whole time. And notice, this is self-reset. This is a self-resetting setup. If you use the done bit, the XIO with the done bit of any timer, that's a way of resetting stuff. And I could do this till I'm blue in the face. It's called cascading timers. And if I want to, let me go offline. And let me just put another branch in here. Now you can do this in separate runs too, but I'm just do this for sake of time. I can put the timer bit here and put another timer in. And I got the RTO timer, so I'll just use that. Now you can create an array of timers, so you can have a bunch of timers to draw from. But basically, now, and let me put in, I know riveting stuff, but let me just put in the light 3 and light 2. So say I have I have 3 timers, 3 lights, okay? And I want the lights to basically go in some type of sequential order. I want to fix something in a second so you can see it better. So maybe you have like racing lights. Let me change this to 1,000. And let's change this to run. And you can see one timer's timing, next one, then the next one. But notice, light, light, light. I'm just using the TT bit and the done bits to kind of coordinate a changing light sequence. Now, if I wanted to change the actual timer preset, I could. To slow one down. And you can see it stays on, the light will stay on here. Then it resets at the back, goes back to the beginning, flips on to the next one and the next one. So this is a way of sequencing, is by using these done bits, and basically the setup is use the last done bit to be the reset of the whole thing, the next done bit to power the next timer, and the next done bit to power the next timer. Kind of a little trick. And I don't want to stoplight you from doing this for other things, but that's a hint if you've ever thought about a stoplight project in a PLC class somewhere. But that is how the basic structure could work. And if I want to program, if I want to do multiple lights at a time, just take it off the TT bit, or hold on. If I want certain lights to be on a certain amount of sequence, I can just add a rung here, and I can put in another TT bit and say if I want that light on for, you know, twice. Because the thing of these timers is steps in the sequence. And I hope you think you can see some value in this. But those are some tricks. The other thing I'll show you really fast too is, let me delete all this. But let me start with this. This is a good setup. If I go into timers, I can use the enable bit of a timer, and we'll just call this RTO. To basically lock in something if I wanted to. But remember, if you're going to seal in something, make sure you have a way to get it out. So I'm going to put a push button 2 in here. And let's just make this be a done bit. Because so you can seal in things as well. And let me just make this XIC, because we're using bits. So we download. So don't just think about timers as just a push button controlling something. You can do all the other programming we've learned with timers and make it serve your benefit. It's just asking about what I want it to do. If I toggle that bit, if I untoggle the bit, you can see that it is sealed in and still times. Cool. And let me just do one little other quick trick. Let me use a retentive timer, because this will come in handy later. Sometimes with a scan cycle, if you do it the first way I showed you, it resets really fast and you can't like do something else with it. But this way forces it to go through the whole scan cycle. This will make more sense when we start using counters. And so say I'll just keep this here. And let me do, I'm just gonna keep this live so I can just show you the point. All right, so let me download this and I want to show you. Because you don't always need the retentive timer to remember stuff, but you could use it to make sure something stays engaged even when you drop power from the rung. And so now this is on, I toggle the bit, it works. If I untoggle the bit, because if I keep that bit on, so I keep it resetting. But now watch what I do. If I make it the done bit down here, I do the same thing as I did before. Some people like this better because they can physically see it and it forces it to stay on, but I'm using that done bit to reset the timer in this way. So I'm not using this funky XIO, not the timer timing thing. You can do something like this too. And this is good. So say you have a bunch of stuff in between, like if you have a bunch of stuff in your rungs between the timer and the reset, you can make sure if this done bit is being used to do something in between the timer and the reset, you make sure it's done because the reset command is put after the fact. This will come in handy next week when next time we start talking about counters. All right. So I hope this helps demystify timers. It is something that you can't ignore it in PLC programming, but these are some of the tricks that you can utilize.